Hello students of class 10 Advanced Mathematics, exercise 2.4, question number 1. Determine the amplitude of each of the following complex numbers. Okay, determine the amplitude of each of the following complex numbers. So this is -1 plus I. So let Z is equals to -1 plus I. Okay. So in here, first of all, I will find, you see, -1 equals to Z equals to -1 plus I equals to, I can write it as -1 comma 1, which lies, this point, which lies, you see, in the second quadrant. Yes, which lies in the second quadrant. Okay, this one you can see here. This is positive, positive. This is negative, positive. This is negative, negative. And this is positive, negative. Negative, positive. This is which lies in the second quadrant. Okay. So therefore, amplitude of Z, it will be is equals to amplitude of Z, second quadrant, it will be is equals to pi minus alpha. Okay. Now, tan alpha is equals to modulus y by modulus x. Okay. Is equals to modulus 1 by, this is y, this is x, modulus minus 1. This is equals to 1. So tan alpha, you see, this is tan alpha is equals to tan theta 1 becomes, when theta is 45 degree. So this becomes is equals to, instead of writing 45 degree, I will write pi by 4. Okay, in here pi is 180 degree. 180 if you divide it by 4, 4 for the 16, 20, 4 5 is 45 degree you will get. So in place of 45, I can write it as pi by 4. So in here I will get alpha is equals to pi by 4. Okay, in here I will get alpha is equals to pi by 4. So therefore, amplitude of Z, it will be is equals to pi minus alpha there. So pi minus alpha value I got pi by 4. So pi minus pi by 4. So this gives me is equals to 3 pi by 4. Okay, amplitude of Z, it will be 3 pi by 4. Exercise 2.4, question number 1, number A. You see this is 3 pi by 4. This is our answer. Okay. Next again number B. 1 by 1 plus I. So 1 by 1 plus I will multiply both sides by 1 minus I. This I will get 1 minus I by 1 minus I square. So this is 1 minus I by 1 plus 1. So this gives me I minus 1 minus I by 2. So this one equals to, I can write 1 by 2 plus minus 1 by 2I. Okay, which is equals to, I can write as 1 by 2 comma minus 1 by 2. So this point which lies in the which quadrant it lies? X-axis positive, y-axis negative. It lies in the fourth quadrant. Yes, it lies in the fourth quadrant. Okay, which lies in the fourth quadrant. So therefore amplitude of okay, you can write in this way: amplitude of 1 by 2 plus minus 1 by 2 I, amplitude of this complex number, it will be is equals to fourth quadrant, it will be is equals to minus alpha. It will be is equals to minus alpha. Okay, it will be is equals to minus alpha. So therefore, first of all, tan alpha, I have to find the tan alpha. Tan alpha, it is equals to modulus y by modulus x. So modulus y, in here it is minus 1 by 2 by modulus 1 by 2, which is equals to, you will get 1 by 2 by 1 by 2, which is equals to 1. So therefore tan alpha is equals to tan 45 degree, means 1 when becomes tan 45 degree. So you can write this pi by 4. So alpha is equals to becomes pi by 4. Okay, alpha is equals to become pi by 4. Okay, so therefore you can say that, you see, amplitude of this complex number, it is minus alpha. Alpha value I got pi by 4. So therefore you can write amplitude 1 by 2 plus minus 1 by 2 I. Amplitude, this is equals to minus pi by 4. This is the answer, minus pi by 4. If you check the back answer here, it is minus pi by 4. Okay. Next you see number C, I by 1 plus I, solution. So in here again, I by 1 plus I, both side 1 minus I, 1 minus I. This is I, this becomes, let us multiply it, I minus I square by 1 minus I square. So this is I plus 1 by 1 plus 1. So this gives me I plus 1 by 2. So this one I can write it as is equals to I by 2 plus 1 by 2, which I can write it in this way, 1 by 2 plus 1 by 2 I. Okay, I can write it as. So if you want, you can say that let z is equals to 1 by 2 plus 1 by 2 I, which is equals to, if you write this complex number in ordered pair, it will become 1 by 2 comma 1 by 2, which lies, this point lies on which quadrant? This point lies on the first quadrant. Yes, lies on the first quadrant. So therefore amplitude of z, it will be what? Amplitude of z, it will be alpha. Okay, amplitude of z, it will be alpha. So now tan alpha, it is equals to modulus y by modulus x. It is equals to modulus 1 by 2 by modulus 1 by 2, which is ultimately 1 only. So tan alpha is equals to 10 pi by 4. Alpha is equals to pi by 4. Okay, alpha is equals to pi by 4. So therefore amplitude of z, it is alpha. Alpha is equals to pi by 4. Amplitude of z, this is pi by 4. Okay, amplitude of z answer, it is pi by 4. Next again, number D, you see I minus root 3. So this one you can write as let z is equals to minus root 3 plus 1 into I. This is a plus ib form. Okay, which is equals to, you can write as minus root 3 comma 1, which lies on the which quadrant it lies. X-axis positive, y-axis x-axis negative, y-axis positive. X-axis negative, y-axis positive. So second quadrant lies on the second quadrant. Yes, the following lies on the second quadrant. So lies in the second quadrant. Therefore, you can say that amplitude of z, it will be lies on the second quadrant. So amplitude of z, it will be pi minus alpha. Tan alpha is equals to modulus y by modulus x equals to modulus 1 by modulus minus root 3, which gives me 1 by root 3. Now tan alpha is equals to 1 by root 3. So tan alpha is equals to 1 by root 3, it becomes tan 30 degree. Okay, tan 30 degree, it is 1 by root 3. Understand? Tan 30 degree, it is 1 by root 3. So 30, how I can write? 30 I can write as 180 by this is a 1, this is 6. If I do, then it gives me 30 gives me. So I can write as pi by 6. Understand? So alpha is equals to I get pi by 6. Okay, alpha is equals to I get pi by 6. So therefore amplitude of z is equals to pi minus pi by 6, which ultimately gives me 5 pi by 6. Okay, 5 pi by 6. This is my answer. Okay, 5 pi by 6. This is my answer. So rest problems, again I will do number, let's do number G, 1 plus 2i by 1 minus 3i. So this one, first of all, I will do 1 plus 2i by 1 minus 3i, 1 plus 3i, 1 plus 3i. So this 1 plus 3i plus 2i, 1 plus 3i by 1 square minus 3i the whole square. This gives me 1 plus 3i plus 2i plus 6i square by 1 minus 9i square. Okay, so this ultimately gives me 1 plus 5i minus 6 by 1 plus 9. So this is minus 5 plus 5i by 10. If I take 5 common here, 5 minus 1 plus i by 10, this gives me minus 1 by 2 plus I by 2, which is I can write as minus 1 by 2 plus I 1 by 2. Okay, so now I can take that this one I got. So now I can take that let z is equals to minus 1 by 2 plus I 1 by 2, which is equals to 1 by 2 this one, which lies this point, which lies in the which quadrant it lies, minus 1 by 2 and 1 by 2. X-axis your x-axis negative, y-axis positive, second quadrant, which lies in the second quadrant. Yes, which lies in the second quadrant. So therefore amplitude of z, second quadrant amplitude of z, it is pi minus alpha. Now tan alpha is equals to modulus y by modulus x. Modulus y, this is 1 by 2, modulus x, this is minus 1 by 2, which ultimately gives me 1. So tan alpha is equals to 1 means 10 pi by 4 I can write. Alpha is equals to pi by 4 I will get. Understand? Alpha is equals to pi by 4 I will get. So therefore amplitude of z, it is pi minus pi by 4, which gives me 3 pi by 4. Let us check the answer. Type 1 number G. Type 1 number G, 3 pi by 4. Understand? So rest of the problems you try to do by yourself. This is how we find the amplitude. Next we will go question number 2. Now question number 2, the question is write the polar form. Write the polar form of each of the complex. Write the polar form of each of the complex numbers given below. Write the polar form of each of the complex numbers given below. 1 plus I. Okay. I have to write the polar form. That means in r theta form also you can say. So in here you can say let z is equals to 1 plus I, which is equals to r cos theta, which is equals to, you can write it as r cos theta plus I r sin theta. Okay, plus sin theta. So where r it is modulus z and theta it is amplitude of z. Okay, theta is the amplitude of z. So now in here r is equals to modulus z is equals to root over 1 square plus 1 square. This is the complex number. So modulus of z, it will be 1 square plus 1 square, which is root 2. R is equals to, you got how much? Root 2 you got, which is equals to root 2. R is equals to, you got root 2. Okay. Now you see z is equals to 1 plus I, which I can write in 1 comma y, which lies in the first quadrant. Which quadrant it lies? It lies in the first quadrant. Understand? It lies in the first quadrant. So therefore theta is equals to amplitude of z, it is equals to first quadrant. First quadrant it is alpha, which is equals to alpha. Understand? Now next again I will take now tan alpha is equals to modulus y by modulus x, which is equals to modulus y, it gives me 1 by modulus x1, which is equals to 1. So tan alpha 1 when it becomes, when it is tan pi by 4. So alpha is equals to pi by 4 I will get. Understand? Alpha is equals to how much I got? Pi by 4. Therefore theta is equals to amplitude of z is equals to pi by 4 I will get. So therefore the polar form of 1 plus I is, okay, the polar form of 1 plus I is, you can write it in this way, r cos theta plus I r sin theta. R value how much you got? Root 2 I got. So therefore root 2 bracket start, because from here r cos theta plus I r sin theta, from here if I take r common, okay, 1 minute, let me see, z is equals to this one, so z polar form of this is okay, no problem. So if I take r common here, understand, so r value it is root 3, so root 3 cos theta value how much I got? Theta value pi by 4 I got. So cos pi by 4 plus I sin theta again pi by 4. So this is the polar form of 1 plus I. Understand? This is the polar form of 1 plus I. So in this way you can do. Okay. Next again you see number C. 3 minus 4i to the whole power minus 1. 1 plus 7i. Okay. So in here solution. First of all let me solve it a little bit. 1 plus 7i. So this is equals to 1 plus 7i by 3 minus 4i. So 1 plus 7i by 3 minus 4i into 3 plus 4i into 3 plus 4i into 3 plus 4i. So this one it will become 1 3 plus 4i plus 7i 3 plus 4i by 3 square minus 4i the whole square. So this is ultimately I will get 3 plus 4i plus 21i plus 28i square by 9 minus 16i square. So this one it will give me 3 plus 25i minus 28 by 9 plus 16. So this is minus 25 plus 25i by 25. 25 if I take common, minus 1 plus I by 25 minus 1 plus I will get. Okay, minus 1 plus I will get. Understand? So this is equals to, how I can write, minus 1 comma 1 I can write. Yes, this is equals to minus 1, or you can take let z is equals to this one is equal to, no problem. This is equals to, I can write minus 1 comma 1 I can write. Finished. One minute. Instead of writing this, first of all I will say is equal, this one, this thing I solved it a little bit, and I got this. This is the complex number. Yes. So now I will take a let. Okay, let z is equals to minus 1 plus I, which is equals to r cos theta plus I r sin theta. Yes, r cos theta plus I r sin theta. So where r is equals to modulus z, and theta, this is equals to amplitude of z. Yes, theta is equals to amplitude of z. So r is equals to modulus z is equals to root over minus 1 the whole square plus 1 square. Understand? So this gives me root over 1 plus 1. This is root over 2. R value I got, it is root over 2. So now minus 1 plus z is equals to minus 1 comma 1, which lies, this point lies minus 1 1, which lies in second quadrant. Yes, which lies in second quadrant. So therefore theta is equals to amplitude of z is equals to second quadrant, it is pi minus alpha. Yes, it is pi minus alpha. So tan alpha is equals to modulus y by modulus x is equals to 1 by modulus minus 1 is equals to 1 only I will get. So tan alpha is equals to 10 pi by 4 you will get. Alpha is equals to pi by 4 you got. Understand? Alpha is equal to pi by 4 you got. So therefore this one, remember, r is equals to root 2 I got. Okay, I will have to rub this. So therefore theta is equals to amplitude of z is equals to pi minus pi by 4 I will get. This one I will get 3 pi by 4. So therefore you can say the polar form, of minus 1 plus I is this will be root 2 bracket start cos 3 pi by 4 plus I sin 3 pi by 4. This is the answer. Understand? Let's check the back answer. Type 2. Let's check the back answer here. Type 2 number C. Type 2 number C, root 2 cos 3 pi by 4 plus I sin 3 pi by 4. This is the answer. So this is how we write a complex number in polar form. Okay, this is how we write complex number in polar form. Understand? So next we will go to question number 3. Express the following complex number, express the following complex numbers in the polar form. Express the following complex numbers in the polar form. Number 1, it is sine 30 degree plus I cos 30 degree. Okay, so polar form, remember, it is cos theta. It is cos theta plus I sin theta. Okay, polar form, it is cos theta plus I sin theta. Okay, so in here you see I will do solution. I will do let z is equals to sine 30 degree plus I cos 30 degree. Okay, and its polar form is r cos theta plus I sin theta. Okay, and its polar form is r cos theta plus I sin theta. Now you see z is equals to sine 30 degree plus I cos 30 degree. So sine 30 I can write as sine 90 minus 60 I can write plus I cos 30 I can write 90 minus 60 I can write. So this becomes cos 60 plus I sin 60 becomes. Okay, I sin 60 becomes, which is equals to, in a r value you see cos theta plus I sin theta form I got, and r value it will be 1. So 1 dot cos 60 degree plus I sin 60 degree. Understand? In here r value it is 1 and theta value it is 60 degree. Okay, which is the, you can write, which is the required polar form of z, which is the required polar form of z. Okay, so rest of the problems you try to do by yourself. I think it will be not so much difficult for you. If you are not able, you please write it in the comment section. Next we will go to question number 4. Verify the property amplitude z1 z2 is equals to amplitude z1 plus amplitude z2 for the following complex numbers. Okay, number 1, minus 2 plus 2i 1 minus I. Verify the property amplitude z1 z2 is equals to amplitude z1 plus amplitude z2. Okay, so in here first of all I will take, let z1 is equals to minus 2 plus 2i and z2 is equals to, this one I will take 1 minus I will take. Okay, so now z1 into z2 minus 2 plus 2i 1 minus I, if this one if I multiply to minus 2 1 minus I plus 2i 1 minus I minus 2 plus 2i plus 2i minus 2i square minus 2 plus 4i plus 2i will get, so 4i, this is the answer. Okay, which I can write it as 0 plus 4i, which is equals to 0 comma 4, this one, which lies, this point lies on the positive part, lies on the positive part of the real 0, sorry, this is 0 comma 4, which lies on the positive part of the imaginary axis. Okay, which lies in the positive part of the imaginary axis. Okay, which lies in the positive part of the imaginary axis. So now in here you see we have already discussed, in our previous videos we have already discussed that now this point you see it lies on the imaginary axis. Okay, lies on the positive part on the imaginary axis. This is the positive part of the imaginary axis, that means 4 0, this point lies in here. Yes, so now if the point lies on the imaginary axis, then its amplitude, you see, if it lies on the positive part of the imaginary axis, then its amplitude is pi by 2. Okay, its amplitude, it will be pi by 2. Okay, so therefore I can say that, therefore amplitude of z1 z2, this is equals to pi by 2. This is equals to pi by 2. Okay, this is equation number 1. Okay, next you see this is our over. So next, let me write this thing. Amplitude Z1 Z2 is equals to pi by 2. I got this is equation 1. Z2 is equals to 1 minus I. Okay. Now you see, this is Z1, amplitude Z1. Okay. Let me say. Okay, no problem. You can write amplitude Z1 is equals to amplitude Z1. You see, this is minus 2, 2. Okay, the point represented by the complex number, it is minus 2, 2. So x coordinate negative, y coordinate positive. That means it lies on the second quadrant. Yeah? Yes, it lies on the second quadrant. Okay, it lies in the second quadrant. So therefore amplitude, it will be pi minus alpha, since PZ1 lies on the second quadrant. Since PZ1 lies on the second quadrant. Okay. So now you see, now tan alpha, it will be is equals to modulus y by modulus x, which is equals to 2 by minus 2, which gives me is equals to 1. So tan alpha is equals to 10 pi by 4. Alpha is equals to pi by 4 I will get. Okay, alpha is equals to pi by 4 I will get. Understand? So therefore amplitude Z1, it will be pi minus alpha value pi by 4, 3 pi by 4. Amplitude of Z1 I got 3 pi by 4. Finished? 3 pi by 4. Now next I will have to find. So this is over. I will write here amplitude Z1, this is equals to 3 pi by 4. Done. Next I will find amplitude Z2. Amplitude Z2, this will be amplitude Z2. You see, this is 1 minus 1. Okay, the point represented by this complex number, it will be what? What will be the coordinate of this point? 1 minus 1. 1 minus I there. So it will be 1 minus 1 comma minus 1. So this point lies where? X axis positive, y x coordinate positive, y coordinate negative. That means it lies on the fourth quadrant. So therefore amplitude, it will be minus alpha, since PZ2 lies on the fourth quadrant. Since lies on the fourth quadrant. Okay. So now tan alpha, it will be modulus y by modulus x is equals to, I will get minus 1 by 1, which will be ultimately 1 only. So tan alpha, it will be pi by 4, tan alpha, it will be 10 pi by 4, 10 pi by 4. So therefore alpha is equals to, I will get pi by 4. Alpha value I got. So therefore amplitude Z2, this will be is equals to minus pi by 4. Okay, amplitude Z2, I got it is minus pi by 4. Amplitude Z2, this is minus pi by 4. Understand? Now I will have to verify the property, this one. Okay, I have to verify here. So therefore let's give it equation number 2 and let's give it equation number 3. So equation 2 plus 3 I will do here. Okay, equation 2 plus 3. So this is, I will get amplitude Z1 plus amplitude Z2, which is equals to 3 pi by 4 plus minus pi by 4. This will be 3 pi by 4 minus pi by 4, 2 pi. So this gives me is equals to pi by 2, and this is what? This is equals to This is equals to amplitude Z1, Z2. This is hence verified. Okay, this is hence verified. Pi by 2 I got, which is amplitude Z1, Z2. Understand? So in this way you can do these things. Next time number 2 you try to do by yourself. Okay, and then next it is question number 5 there. Question number 5 saying that verify the property amplitude Z1 by Z2. This is equals to amplitude Z1 minus amplitude Z2 for the complex number, for the complex numbers given below. For the complex numbers given below. First one, root 3 minus I by 1 minus root 3I. Okay, verify the property amplitude Z1 by Z2 is equals to amplitude Z1 minus amplitude Z2 for the complex numbers given below. So in here I will take first one, let Z1 is equals to root 3 minus I and Z2 is equals to 1 minus root 3I I will take. Okay. So now Z1 by Z2 is equals to root 3 minus I by 1 minus root 3 I will get, which is equals to root 3 minus I 1 plus root 3 I will do, and 1 minus root 3 I 1 plus root 3 I will do. So this is equals to I will get root 3 1 plus root 3 I minus I 1 plus root 3 I by 1 square minus root 3 I the whole square. Okay, so this is equals to I will get in here root 3 I plus 3 I minus root 3 I square I will get by 1 minus 3 I square. So this is root 3 plus 2 I plus root 3 by 1 plus 3 I will get. So this is have I done some mistake? Root 3 okay, so this one root 3 plus root 3 I will get twice root 3 plus 2I by 4 I will get here. Okay, so from here if you common take root 3 plus I by 4, which is ultimately you will get root 3 plus I by 2 you will get. Okay, root 3 plus I by 2 you will get. Okay, so this one is equals to, you can write this is equals to root 3 by 2 comma 1 by 2. Okay, which lies in the this point where it lies, x coordinate positive, y coordinate positive. This point lies in the first quadrant. Yes, you can write which lies in the first quadrant, So therefore you can say, therefore amplitude Z1 by Z2, this is equals to it lies in the first quadrant, so its amplitude it will be alpha. Now tan alpha is equals to modulus y by modulus x, which you will get modulus 1 by 2 by modulus root 3 by 2, which is equals to 1 by 2 by root 3 by 2. This is equals to ultimately you will get 1 by root 3 you will get. Understand? 1 by root 3 you will get. So tan alpha 1 by root 3 when becomes 1030 becomes. So this is instead of 1030 I can write here 10 pi by 6 I can write. So alpha is equals to pi by 6 I will get. Understand? Alpha is equals to I will get pi by 6. Okay. So therefore alpha is equals to I got pi by 6. So therefore I can say, therefore amplitude of Z1 by Z2, this is equals to pi by 6. Amplitude of Z1 by Z2, this is equals to how much I got? Pi by 6 I got. Okay. So, okay, this is equals to pi by 6 I got. So, therefore, I will write amplitude Z1 by Z2, this is equals to pi by 6 I got. Now, next you see, Z1 is equals to root 3 minus I, which is equals to, you can write root 3 comma minus 1, which lies, this point lies on the fourth quadrant. This point lies on the fourth quadrant. So therefore amplitude of Z1, fourth quadrant, amplitude of Z1, it will be minus alpha. Okay, now tan alpha is equals to modulus y by modulus x, modulus y, which is minus 1 by modulus x root 3, this is equals to 1 by root 3. Again, tan alpha is equals to 10 pi by 6 you will get. So alpha is equals to pi by 6 you will get. Understand? Alpha is equals to pi by 6 you will get. So therefore amplitude Z1, it is minus alpha. So therefore amplitude of Z1, this will be is equals to minus pi by 6. Okay, understand? Amplitude, so this one I got amplitude Z1 is equals to minus pi by 6 I will get. So in here you see this one Z2 is equals to 1 minus root 3I, which is equals to 1 comma minus root 3. Okay, which lies in the fourth quadrant. Okay, this point lies in the fourth quadrant. Understand? This point lies in the fourth quadrant. So therefore amplitude of Z2, it will become fourth quadrant, it will become minus alpha. Okay, now tan alpha, it is equals to modulus y by modulus x. So modulus y, it is given as minus root 3 by 1, which is root 3. So tan theta, when it becomes root 3, when theta is 60 degree. So tan alpha is equals to 10, 60 degree I can write as pi by 3. So alpha is equals to, I will get pi by 3 I will get. Okay, alpha 10 pi by, 60 root 3, so pi by okay, so alpha is equals to, I will get pi by 3 I will get. So therefore amplitude of Z2, it will be minus pi by 3. Okay, and root 3, it is 60 degrees, 180 by 3, yes, 60 degrees I will get. So minus pi by okay. So in here I got amplitude of Z2, in here I got minus pi by 3 I got. Okay, amplitude of Z2 I got minus pi by 3. So now amplitude of Z1 minus amplitude of Z2, it will be minus pi by 6 minus bracket minus pi by 3, which is minus pi by 6 plus pi by 3. So this is ultimately I will get is equals to, LCM will be 6 minus pi plus 2 pi, it will give me pi by 6. Okay, it will give me pi by 6, it will give me. Understand? So pi by 6, these are pi. Okay, it looks like 5 here, these are pi. So pi by 6, this is what? Pi by 6, amplitude Z1 by Z2. So this is equals to, I can say, amplitude Z1 by Z2. Understand? This is verified. So next it is type 6. If amplitude of Z equals to phi, then find the following. Number A, amplitude Z bar. Okay. So question number 6, it is given if amplitude Z, this is equals to phi, then find the following. So first of all, you see number A, amplitude Z bar. Okay, so this is solution. You see it is given in your book. Amplitude Z bar, it is equals to minus theta, it is equals to minus amplitude Z. Okay, so therefore amplitude of Z, it is equals to phi. So therefore amplitude Z bar, this is equals to minus amplitude of Z, so this is equals to minus phi. Okay, again B and C, number B and number C. Number B, it is given amplitude minus Z, and number C, it is given amplitude IZ. These two we will do a little bit later. Okay, I will not do in this video. I have done only number A. These two I will do in next video. I will do. Okay, so next, this is question number 7. Fill in the blanks. If A belongs to R and A less than 0, then amplitude of A is equals to. Okay, A belongs to R and A less than 0. Okay, A belongs to R and A less than 0. I have to find amplitude of A. So in here you see Z is equals to A. Okay, this is A. So this one Z is equals to, I can write A plus I dot 0. The complex number is A plus I dot 0. Okay. So sorry, not A, this is minus A. Okay, because A is less than 0, so minus A. Z is equals to, I can write Z is equals to minus A plus I dot 0, which is equals to, I can write minus A dot 0, and this point it lies, this point lies on the negative part of the real axis. Yes, this point lies on the negative part of the real axis. Yes, so you see in here, if the point lies on the negative part of the real axis, then its amplitude is pi. So therefore amplitude of A will be pi. Okay, amplitude of A will be pi, because this point, it lies in here. Yes, it lies on the negative part of the real axis, then its amplitude is pi. Next it is number B. Next it is, you see, number B. If B belongs to R and B less than 0, then amplitude IB. Okay, so in here you see B belongs to R and B less than 0, amplitude IB. So this one, you see, this one I can write as Z is equals to 0 plus IB. Yes, Z is equal to 0 plus IB. So this is equals to 0 comma B. Okay, this is equals to 0 comma B. So oh sorry, this, you see, B less than 0, so this is equals to Z is equals to 0 minus IB, it will be, which is equals to 0 comma minus B. So this is the point. Okay, So this point, it lies 0, it lies here. Yes, it lies here. It lies on the negative part of the imaginary axis. You see, it lies on the negative part of the imaginary axis. It lies on the negative part of the imaginary axis, then the amplitude is minus pi by 2. Okay, so amplitude IB, it will be minus pi by 2. Okay, next it is number C. If B belongs to R and B greater than 0, then amplitude IB, it will be is equals to. So this one I can write as Z is equals to 0 plus IB, which is 0 comma B. Now this, you see, it lies on the real part. It lies on the real part of the, or sorry, it lies on the positive part of the imaginary axis. Then amplitude is pi by 2. Okay, amplitude of IB, it will be pi by 2. Okay, then next it is number D. Next it is number D. Number D saying that if Z is not equals to 0, then amplitude Z plus amplitude Z bar, this is equals to. Okay, if Z not equals to 0, then amplitude Z plus amplitude Z bar is equals to amplitude Z plus amplitude. So this one, you see, this one, you see, amplitude Z plus amplitude Z bar, that means amplitude Z, this one we know amplitude Z bar, this is equals to minus amplitude Z. Yes, amplitude Z bar, this is equals to minus amplitude Z. So this one, it will become minus amplitude Z. Okay, so this is equals to 0. Amplitude Z minus amplitude Z, this is equals to 0. Okay, and then the last one, number E, amplitude 1 plus I plus amplitude 1 minus I, this is equals to amplitude 1 plus I plus amplitude 1 minus I. Okay, so again, this is, you see, amplitude 1 plus I. If 1 plus I and 1 minus I, 1 minus I is a conjugate of 1 plus I. If this is, I consider it as Z, and this is Z bar. So therefore, amplitude 1 plus I plus amplitude plus amplitude 1 minus I, this is equals to amplitude 1 plus I minus amplitude 1 plus I. Okay, so this is equals to 0.